Welcome to the new lecture of our
Series on distributed system. In this lecture, we are going to discuss remote communication, which we have previously introduced in our previous lecture. Now we are going to discuss the parameter passing semantics in message passing mechanism. There are basically three types of semantics involved. First, we can either be choosing call by value, or we can be choosing call by reference, or we could choose call by copy or restore. So in call by value, what we do is we copy all parameters into a message, and these parameters are embedded in the message before the transmission of the message. Then call by reference. In call by reference, what we do is we pass the parameters in the form of pointers to the actual value. So what parameters are? Basically the parameters are the pointers that are passed from the client to the server. Now the third one, call by copy or restore semantics. In call by copy or restore semantics, what we use is we use temporary storage accessible to both the programs. So basically what involves in this copy or restore is there is a flexibility of temporary storage which is accessible to both the programs. Now we'll talk about byte ordering, which is useful in data representation. So there are two, basically one is little endian and second is big endian. So if you look at little endian, what it goes around is like it starts from least significant bit and on the left hand side, and then keeps on going like that. And in big endian, it is vice versa as compared to little endian. Now we'll talk about server management. So when we are doing the implementation of a server, we need to consider what the server state would be, whether we will be keeping a stateless server or we will be requiring a stateful server. So it has to be considered while building our distributed system. Then we talk about server management. So server management, basically what it does is what we need to concentrate on how we will be evaluating our server or managing our server. Will it be instance per call or instances per session or persistent server? So these are basically things which we need to consider before building our distributed system as per the perspective of our server. Now we are going to discuss RPC call semantics. What usually happens in RPC is that the caller and callee are processes are usually situated on different nodes. So the normal functioning of an RPC may get disrupted due to multiple reasons, which can either be like your message is lost or the response is lost, or the caller or the callee node may crash. So in RPC system, the call semantics determine how often the remote procedure may or should be executed under fault conditions. So the different types of RPC call semantics are firstly possibly or maybe call semantics. Actually, it is the weakest semantics in which a timeout mechanism is used which prevents the caller from waiting indefinitely for a response from the callee. What this means is, this means basically that the caller waits until a fixed period of timeout and then continues to execute. So this semantics usually do not guarantee the receipt of call message nor the execution, and it is applicable where the response message is usually less important. An application that operate within a local network can work with uh, the this kind of strategy. Now we'll talk about last one, call semantics. This semantics is based on the idea of retransmitting the call message based on timeout until the caller receives a response. And the call execution and result will keep waiting until the result of procedure execution is received by the caller. So what here we are doing is we are following the concept of timeout, but what we intend to do, we intend to resend the message. So the result of the last executed call are used by the caller, and it is also therefore it is known as last one semantics, and it can be easily implemented when two nodes are involved in the RPC, but the it is a bit of tricky because nested RPC may call cases of orphan calls where the node have crashed. And then we'll talk of last of many call, and this semantics basically neglect orphan calls unlike last one call semantics. And as you know, orphan call is the one where caller has expired due to node crash and is unable to receive messages. So to identify each call, what we do is we assign unique identifiers and which are used further to neglect our orphan calls. When a call is repeated, it is assigned a new call identifier, and each response message has a corresponding call identifier. So by assigning new identifiers, what we are able to track is we are able to track orphan calls, and a response is accepted only if the call identifier associated with it matches the identifier of the most recent call, else it is ignored. So what it basically does, it is able to handle our orphan calls. Then we have at least once called semantics, and this semantics usually guarantees that the call is executed one or more times but does not specify which result are returned to the caller. So what is the situation that the execution is sure, but we do not know which execution did happen. It can be implemented using timeout based retransmission and without considering the orphan calls. Then we have exactly one call semantics, and it is basically the strongest and most desirable call semantics. It eliminates the possibility of a procedure being executed more than once irrespective of the retransmitted call. So what it does, it ensures that the procedure is executed, and the implementation of exactly once call semantics is usually based on timeout, retransmission, call identifier with the same identifier for repeated call, and a reply cache associated with the caller. So it is our strongest form of RPC call semantics. Now we'll talk about RPC communication protocol. First is the request protocol, and the second is the request reply protocol. Third is request reply acknowledgement reply protocol. So now we'll talk about request protocol. In request protocol, there is only request made from client to the server, and the response is usually not received. So in request, only the client uh, sends the request message to the server. Okay. In request reply protocol, a request is usually followed by a response from the server. So as the request is made from the client to the server, there is a reply message from the server to the client, and the reply message only act as an acknowledgement also. There is no separate scope for acknowledgement of the message. In request reply acknowledgement reply protocol, what usually happens is first request is made by the client and the request is supplied with a reply message by the server after the procedure execution, and on receiving the reply message from the server, what the client does is it replies with the acknowledgement that it has successfully received the message. So this is our request reply acknowledgement protocol. Now we'll talk about client server binding process. So first thing what binding agent needs to identify is it needs to register the server with the binding agent. So first step is server should give ID, address and handle to the binding agent. Then what usually the process is what happens is like the client, what client does it requests binding agent for server address because the client doesn't have the server address. So in turn what binding agent does is binding agent returns server address to the client, and after receiving the address of the client address of the server, then the client can add up the primitives like register, deregister, lookup, and with the address of the server it can call the server directly. So this is our client server binding process. So there are several issues in client server binding, like the naming of the server locating, how will be the server named, how will be the where will be the server located, and there are furthermore type of binding in which there is a firstly a fixed binding, and on there can be like dynamic binding which can be at compile time or link time or runtime. So there are multiple issues which need to be dealt with, and further there are like primitives involved with binding agents such as register, deregister, lookup. So taking into consideration how the actual picture should be, we need to specify and deal with each of the things in detail. Now we'll talk about some other RPC issues. So other RPC issues basically includes exception handling and security. Exception handling because there as we talk about distributed environment, there are wide complexity of exceptions involved, like whether the resource was earlier available and now not available, and multiple situations like that. And security is always a concern when we talk about distributed system. And failure handling, how to handle failures if a node has crashed or the server has crashed. So failure handling is also an RPC implementation issue. And then what we need to do is we need to optimize our RPC execution, and there are various type of complicated RPCs which need to be taken care of. While talking about heterogeneous environment, what complexity does it add? What basically the data representation is a typical issue while we talk about heterogeneous environment, and the transport and control protocol needs to be altered, because homogeneous environment is a simple environment in which all nodes have all the similar configuration and same capabilities. But as soon as we talk about heterogeneous environment, like the size of the bus and the data buffer and all changes, so there is a need to alter our protocol so that it can satisfy the need of the heterogeneous environment. Now we'll talk about failure handling mechanisms in RPC. So what kind of failure could happen is, firstly, the client cannot find the server. So maybe because of some binding agent or some any other issue, the client is unable to find the server. Then the other reason could be like request from the client to the server is lost. The client has made the request but it hasn't reached the server and it is lost, or the reply from the server to the client may be lost. Even what happens is sometimes server crashes after getting the request from the client, or the client crashes after sending the request. So these are typical failure which happens in our RPC. And for RPC optimization, what we need is we should allow concurrent access to multiple servers. So for that we require use of threads and early reply technique, in which the as soon as we are able to send the reply to the client, we should as a server send the reply instead of completing the process and then sending the reply in order to save time of the client. And then there can be call buffering. So this concurrent access of to multiple servers, what happens is it speeds up the process. While we are talking about optimization, we are trying to improve the efficiency of the RPC communication. So the second point is serving multiple requests simultaneously so that the work can go on in parallel and we are able to achieve the speed up. Thirdly, we can reduce per call workload of server, which can further enhance the capability of server and speed up the process. Fourth, you can use reply cache for idempotent RPCs. So what it does, it saves the unnecessary computation or complexity involved in replying, and it can just simply reply from the cache. And third and last one, the selection of proper timeout value. It is a key concern to identify the proper timeout value, but if we have chosen the correct timeout value, then we know that whether the message is going to arrive or not, and we can't simply wait unnecessary for the message to come which is not expected to be coming. Then we'll talk about concurrent access to multiple servers. So for that, what we require is we require use of threads so that the process can work in parallel. Then we require early reply technique, which we talked about in the just few seconds before, and call buffering approach, serving multiple requests simultaneously, reducing call workload of server, and using reply cache for idempotent RPCs. So what all that does is it improves the efficiency and of RPC and allows concurrent access to multiple servers. With this, we come to end of this lecture. Keep studying, stay at home, and take care of yourself. Thank you.